All right, nerds. So today we're starting chemistry, and a lot of people we want to talk about what chemistry is and why. Why chemistry? Okay. So essentially, we'll start with chemistry is life. Chemistry is you. Chemistry is me, and chemistry is everything around us. It's just how it works. Okay. So what is chemistry? Well, basically, when we talk about chemistry, we're talking about how matter and energy interact. Okay, I don't know if you've ever really thought about it this way. So the way we focus on it, though, is we focus on the rearrangement of atoms. So, you've got your atoms here, and, you might change this one out for another type. And so we're going to talk about the rearrangement of atoms and the energy that's involved in that. So whenever we rearrange atoms, we get a change in substances. So we'll get a new substance, and that changes the properties, so it changes how useful something is. And so it's important that you are chemistry. You are a complex bag of chemicals interacting with other complex bag of chemicals to survive and essentially make more bags of chemicals like you. That's life. That's why life is chemistry. So the first thing we want to focus on is the law of conservation of matter. This is sometimes called the law of conservation of mass, or the law of conservation of energy, and that's because they're all kind of the different angles of the same thing. So matter is never created or destroyed, or mass is never created or destroyed. It can only be rearranged or transformed from one type to another. So what that means is, in a chemical reaction, if you've got two hydrogens on one side of the equation, you need to have two hydrogens on the other side of the equation. Otherwise, you've not conserved matter. So when we start this off, so if you ignore this 2 at the moment, we've got 1 magnesium, 1 hydrogen, and 1 chlorine. But on this side, we've got 1 magnesium, this little 2 down here means 2 chlorines and 2 hydrogens. Well, that doesn't match up. So if we put a 2HCl on the front, what that means is on this side, we now have 2 hydrogens, 2 chlorines, and 1 magnesium, and that matches up this side. So for this reaction to work, we need to have twice as many hydrochloric acid molecules, than we do magnesium atoms. Okay, so you are essentially what happens to molecules after about 4 billion years of evolution. Like, you're one of the things they become. And this is the chemistry of you. Like, this is over here, this is the chemical makeup of you. You're 60% hydrogen, 26% oxygen, 10-ish, 11% carbon, 2.5% nitrogen, and everything else is a mix that makes that up. And that's cool. Like, that's who you are. What's amazing is if you take helium out of the universe, because helium doesn't interact with many things. If you take helium out of the universe, you've got a very similar chemical makeup to the universe, and a very similar chemical makeup to the Earth. So basically, all organisms on Earth have similar chemistry. Like, if you're a mammal, or if you're a vertebrate animal that lives on the land, you pretty much have this makeup. If you're a fish, you have almost this makeup. And if you're a bacteria, you have almost this makeup exactly. So plants have a bit more nitrogen, but pretty much that makeup. So that's really cool. Like, all life has a very similar makeup. And that's basically because we all survive on the same chemical reaction, and that is the digestion of sugar. So if you're a plant, animal, bacteria, it doesn't matter. You're breaking down sugar for energy, okay? So you break down, or even if you're eating stuff like fat, we break that down into sugar-like molecules and use it for energy. So the elements in our crust and the Earth's crust and us, it's very similar composition. And that's because the elements that make us up come from the Earth. Like, they come from out of the ground. And originally, they came in the very early start of the universe. They come from stars, from inside stars. Essentially, stars died so you could exist. So let's have a quick look at some everyday chemical reactions. So we've got photosynthesis. That's production of sugar molecules from carbon dioxide and hydrogen and water. Okay, breathing, respiration, all those sugar. One of the things you break that down into is carbon dioxide. So you've got to get that out. We run because we burn carbohydrates in a car. Like, cars run because they burn carbohydrates. Onions, the reason we cry is because there's sulfur there, and it vaporizes, it gets in your eyes and upsets them. And basically cooking is a chemical reaction, and that's why we do it. Basically, when we cook, we kill bacteria, and the reason it kills bacteria, and the reason it kills you if you get cooked, is because of chemical reactions. It starts to break down the cells, and then they combust, and yeah, chemistry is everywhere. Chemistry is life. So I hope that made sense. I hope you got some good notes, and don't forget to fill out the form beneath the video. Enjoy.